Now, elements in the third period and beyond in the periodic table are able to make use of vacant d-level orbitals to expand their valence levels. And so sulfur is one of these cases. And so what sulfur is able to do is form 6 covalent bonds with fluorine. So this is a special case. And so sulfur here is the central atom, and it is able to form bonds then with 6 different fluorine atoms at the same time. And each of these fluorines is going to have 6 unbonded electrons around it in its valence shell. Now, when we go to take a look at this at a model of sulfur hexafluoride, and if we spin this around, you'll note that there is 1 fluorine on the bottom, 1 fluorine on top, and the other 4 fluorines are situated, and this is how they get as far apart from one another as possible, at the 4 points of a square. And so looking head on into this, here is the 4 corners of the square of the 4 fluorine atoms about the center atom, the central atom. And so what we're going to do is draw a couple lines here to help us visualize this better. And picture these red lines coming out towards you. And this is like looking at a pyramid from the top. And so this is then, I'll draw it over here as well. So here's our pyramid. Okay, and I'm also going to draw the base of the pyramid here. And so you can picture that there are 4 sides to this pyramid. And remember that there's also going to be a pyramid down below as well. And so since this is an 8-sided figure, and hopefully you can see that, since this is an 8-sided figure, this is called an octahedron. And so that's the shape here. So the shape of this molecule, SF6, is octahedral.